In a previous video, I gave an overview of streams in Java. In this video, I'm going to show a hands-on example, but first a reminder on how streams work. We start with the source of data, and then we go through a series of transformation steps. In this case, we're filtering for all items that are less than 8. Then we're limiting to the top 4. Then we're mapping to change a value of the attribute, which in this case is the color. And then we collect it into a result that we can send back. So let's take a look at how we can implement this in our project. First, compute total gas value is a method I set up a bit earlier to simply compute the value that we have in our gas tank of gasoline. We see that I start by initializing a variable, and then I have a loop that iterates over all of the gas objects and multiplies their value by getting their gallons and multiplying that by price and summing that into this value variable and then finally returning the value variable. Let's consider how we could do this with a stream. Well, first of all, we need a source of data, which is our gasoline. And then we can ask it for a stream because the gasoline is a stack in this case, but it's one of the Java collections framework. So it has that stream method on it that will return a stream. Next, we need to do a transformation. So in other words, these gasoline objects have a quantity, which is the gallons of gas, and then a price, which is the price per gallon. And what we want to do is multiply these together and then sum up the value. So we'll use a special kind of map called mapToDouble, which means, okay, I'm going to take whatever lambda is in here and I'm going to return a double. So we start with our parentheses and then we determine the lambda. So we're going to say we're going to accept a gas object, and what does that represent? Well, notice I'm using the same nomenclature up above as I'm using down below. So gasoline is the collection we're iterating over, and every time we shake hands with an individual object, we store that into this gas variable. So I start by declaring my variable, or my parameter, which we're going to call gas. Then I use that arrow operator to say the lambda that I want to have happen next. So I say gas.getGallons times gas.getPrice. And then finally I use my terminal operation sum. And then let's go ahead. I'll tell you what, I'm going to run these two so that we can see them both run together. So I'm going to store this as we'll say stream sum. And you know what? So that we can verify that they're both doing the same thing, I'll return the I'll put the return statement down below. Let's take a look at another example while we're here. I created this filter string method a while back, which takes user input, takes each word, puts it into a linked list, and then compares that linked list to a map of banned words, and it removes those banned words from that linked list. So they could be obscene words or any other word that we don't want to place in there. But then what we do is we create a new string with the result by using a string builder, and then iterating over all of the independent words and attaching them to this string builder with the append method. And then we simply say string builder.toString. So let's see how we could do this with a stream. Once again, we need to start with a collection, and we'll start with the same collection that we have here called the words linked list. And then stream. And stream says, okay, make this available. And really all we need to do here is a collect function where collect is one of our terminal operators. But we need to tell it how to collect the data and put it together. And for that, we're going to say Collectors.joining and then pass in a space. This is a special collector that's typically used for strings, which means append each of these individual elements together and put a space between them. And then let's go ahead and save this to a new string. Now I'm going to snap a breakpoint on both of the methods that we changed and walk through it. When I hit the Save button, it wants to render a representation of this vehicle down in my list. So let's take a look. Well, actually, the first thing it's going to do is filter any bad words out from the text that I entered when I said a good car, gosh darn it. And let's see. Well, gosh darn it, although I notice now that I didn't use the proper capitalization, so it might not filter those out. But not a big deal. We just want to verify that we get the same results by using a loop as we do by using our stream. So I'll tell you what, I'll go ahead and tell this to run to the end. And let's take a look at what stream words is going to return. A good car, gosh darn it. Now let's take a look at what wordsbuilder.toString is going to return. We see over here, once again, a good car, gosh darn it. So we verified that our stream operation with that collectors joining is going to give us the same result as we would have with the loop that we created up above. So go ahead and tell this one to play. And now we're at the point where we're computing the total gas value. And if you noticed on that form, I put 3 different gasoline units in there. We can see that collection down here in the debugger, so in the variable. So you see gasoline, gallons 5, price 4, gallons 2, price 3, gallons 2, price 4. So different quantities of gas and also different values of gas. So we go ahead and we compute the value by iterating over with our for loop. And we see that the value computed is 34.0. Now let's take a look at the value that's computed by our stream. And once again, 34.0. So we validate that this stream operation here gives us the same result as the loop computation up above. We'll go ahead and continue. Now, we know that streams work really well when we need to take a collection and filter it down. So I'm going to do one more stream. I'm going to add a button to our user interface that will provide a count of high miles per gallon vehicles. And of course, we'll use a stream for this. We create an action listener in our controller class, which is driver form, and we know that this class has a vector that represents the vehicles available. That vector is called all vehicles, declared up here. So let's go ahead and ask that vector for a stream. Then we'll say filter, because we want to only get the high miles per gallon vehicles. And you see I passed a lambda in there where we accept a vehicle. And then on that vehicle, we ask for its miles per gallon, and if it's greater than 40, we consider that a high miles per gallon vehicle, and then we simply take a count of that. We'll save that count into a new local variable. Then we can simply use a JOption pane to show that to the user. I'm going to create a series of vehicles. I'll create one that's not high miles per gallon and 2 that are. So now we have one Sonic that I put as 25 miles per gallon, and then 2 Prius that I put as 50 miles per gallon. So let's see what happens when we click the button and go to the debugger. We have our lambda expression, and as I expected, that returns to us the value 2. And sure enough, it popped up a message that says number of high miles per gallon vehicles 2. So you see, this is where we know that streams work well, because we're starting with one list and we're filtering it down, where we typically would use an if test. In this case, we're simply using the filter operation, and then we're accepting this incoming parameter, we're asking for its miles per gallon, and we're using that as a filter. So this effectively acts like an if test, but with a lot less typing than creating a for loop, which we effectively have here, and then nesting an if test inside of it. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.